Greetings, this is Mark Anderson for Kellogg Community College, and today we're going to look at some difficult trinomials. I call them tricky trinomials, but these are trinomials where the first term of, or the leading coefficient, is not going to be 1. So if we look at just what a general, on how general trinomials are written, they're written in the form of ax squared plus bx plus c. And we're going to focus on the coefficients a, b, and c. In the video I made that talked about easy trinomial factoring, the a term, or the leading coefficient, was always 1. But in the next problems I'm going to do, this large battery of problems, the a term is not going to be 1. It's going to be a number, and actually it's going to be a whole number that's going to be positive, and it's going to be bigger than 1. So that means our old technique of finding two numbers to multiply to make the last and add to make the middle has a twist because of this first number here. Well, what I'm going to do is show you a 4-step process that is going to always give you the correct method, and it's going to, or answer, and it will also use factoring by grouping as its core. Now the first thing we're going to do is we're going to attribute this a and c here. We're going to figure out what this 6 is going to do to help me out. Now the first step is to multiply, I'm abbreviating there, a times or by c. Multiply a times c. In this case, 6 times 12 is going to be 72. 6 times 12 is 72. Now what this means is that we are going to now use this as a target number. The 72 isn't actually in the problem itself, but this is the target number that we're going to need to find two numbers that multiply to make the 72, and in this case, in the general directions, I'm going to have a times c. We're going to find two numbers that multiply, little multiplication symbol here, to make a times c, or 72, and add to make b. Alright, so we're going to find two numbers that multiply to make a times c and add to make b. Now the b in this case is negative 17. So both of these numbers have to be negative and they have to multiply to make a positive 72. Now what I'm going to do is just list my possibilities. Negative 1 times negative 72 makes that, but doesn't make the negative 17 when we add them. That actually makes negative 73. How about negative 2 times negative 36? Again, makes a positive 72 when we multiply them, but it doesn't add to make 17. And we keep going. A negative 3 and negative 24 makes 72, but doesn't make negative 17. And we're going to then move on to negative 4 and negative 18, which makes 72, doesn't make the 17. Negative 6 and negative 12, well, the good news about that, it makes a number that's closer to negative 17, but not negative 17 itself. The next pair that multiply to make 72 is negative 8 and negative 9, which makes 72 when you multiply them, and when you add them, it makes negative 17. Now, it's very likely that you won't be listing all of your different possibilities when doing a problem like this. In fact, what you'll probably do is just kind of guess and check your way through, one set of numbers at a time until you find the number in the middle that works. Now, once you've found your pair that works, what you're going to do in step 3 is you're going to split b. And I have a soft spot for retro gaming, so I always call this the Atari step. The Atari logo is 2 swoops and a stick in the middle, but I use the swoop to split this letter b, or this coefficient in front of x, and make this negative 8x minus 9x. So here I have negative 8x minus 9x, which is where I got my little numbers here. You see these two? How they multiply to make the 72. And there you have the negative 8x minus the 9x. That makes this right here. Now let's draw everything else down. So 6x squared plus 12. And now I have my 4 four-term equation that came from my trinomial. Now what I do with this is, since I have four terms, I'm going to use the grouping technique, which is going to be step 4, grouping. So I'm going to do a little grouping here, so I'm going to see what factors out of here and here, and what factors out is going to be a 2x, leaving me with 3x minus 4. Now out of these two terms, I can factor out a negative 3, which leaves me with a 3x minus 4. Note that I had to factor out a negative 3 to get this match on the inside. Now what we learned from a previous video in factoring by grouping, that you would write whatever's on the outside once, and write the 3x minus 4, or the match, once, and then we have our factored form. You can easily check that this is going to be our factored version by just doing a little mental foil. 2 times 3 is 6, negative 8 and negative 9 make negative 17, and negative 12, or negative 3 times negative 4 is positive 12. So this is the factorization of this problem. I'd like to go through all of those steps again with problem number 16 to show you how we could use steps 1, 2, 3, and 4 to get our factorization. So for this next problem, we will multiply first using the first step to multiply a by c. So that's 6 times negative 24, which makes a negative 144. Now this third term, or this number here, created by the a times c, is negative, which means as I look at factors of the 144, I got to consider one of them to be negative and one of them to be positive. Now that means it doubles my possibilities, but I'm not going to write down the negative or positive until I'm sure I've got the right pair, because my target is to find two numbers that multiply to make negative 144 and add to make 7. So I'm going to start off with 2 and 72. Well, I notice that if I add or subtract these, there's no way I'm making 7. I can make a 70 or negative 70, so I'm on to the next one. And again, you can decide to write these down or just do them in your head until you find the correct combo. 3 and 48 is not going to make 7 because it's going to make 45 or negative 45. Let's try the next one. If I divide 144 by 4, I get an answer of 36. And that's not going to make 7 either. So I got to keep going. Dividing by 5 would give me a decimal. Dividing by 6 is 24. I'm getting closer to 7 because 6 and 24, if I took the difference of those, it'd be a smaller number but wouldn't be as small as 7. Let's try 8 since 7 is a decimal, so 8 and 18. Now the difference of here is 10. We're getting close. 9 and 16. And if I take the difference of these, I get 7. So if my 9 was negative and my 16 is positive, I now get two numbers that multiply to make a negative 144, because negative 9 times 16 is negative 144, and add to make a positive 7. So make my Atari step here, so I get 6x squared. I am then going to also put negative 9x plus 16x minus 24. Now if at this step you felt, but what if I flip these two around? What if I put the 16, here and the negative 9 here? And I'll show you that it actually is not going to matter in the final answer scope, but I'll actually show it to you here just so you can see. Now I'm going to look at my grouping method since I have 4 terms. I've split my b, so I'm looking right there. I'm going to divide by 3x, and that's going to give me 2x minus 3. Now here, I'm going to divide by or factor out a 4, and if I factor, hold on, I can factor out an 8. I can go bigger than 4, almost went too small there. So I factor out an 8, and that's going to give me 2x minus 3, and there I go. I've got my 3x plus 8 to write once, and my 2x minus 3 to write once, and that is my factored answer. It's my factored answer. I can do a quick check. 3 times 2 is 6 for the 6x squared. My inside cables are going to be negative 9 and positive 16, which gives me my 7, and 8 times negative 3 is negative 24. Now let me rewind a little bit and say, well, what would have happened if I had wrote the problem at the split b step as 6x squared plus 16x minus 9x minus 24? This is when I usually get a student who says, hey, I did something different, but I got the same answer as you. Well, what I'm going to do is I'm going to factor out of these two something they have in common. In this case, it's going to be 2x, and that's going to give me 3x plus 4, or excuse me, not 4, 8. Sorry about that. 3x plus 8. And over here, I'm going to factor out a negative 3. If I factor out a negative 3, this gives me a 3x plus 8, and lo and behold, you have an answer of 2x minus 3, and here you have an answer of 3x plus 8. And you can see that 3x plus 8, 2x minus 3 is the same as 2x minus 3 and 3x plus 8, because multiplication is commutative. You can flip them around. So for the next many examples here, I am going to just go through the four steps. You may want to put those at the side to keep track as how I do these. So we're going to move on to problem number 17, which has a little bit of a tricky spot to it. Now what's nice about it is that you'll note that if you go 15 times negative 2, that gives you a negative 30. And this isn't going to have a lot of steps to get my 13 here. In fact, 1 and 30, and then we have, let's see, 2 and 15, and then we have 3 and 10. Now here's the real trick about this problem here. You'll note that this can make 13 and this can make 13, but this is the wrong set. Because you'll note I need to make a negative 30, and these would then have to be, one would have to be negative and one would have to be positive. And if the 3 is negative and the 10 is positive, we can't make negative 13. So the answer is this one. By making the 15 negative and the 2 positive, we then can actually do the problem. Split that up into 15x squared plus 2x minus 15x minus 2. Now I use my grouping method here. Really can't factor out of that much. Can factor out the x like so. And here factor out a negative 1. So 15x plus 2. Alright, so here I have x minus 1, 15x plus 2. And there's my end of the problem. So it really all depends on how good you are at, writing these out and figuring out which one it is. If I look at this problem, I multiply 8 times 5, which gives me 40. Now what I'm going to do is I'm actually just, instead of listing all the factors of 40, because it's 1 in 40 and so on and so forth, I'm just going to mentally guess and check. So 1 times 40 wouldn't give me that negative 22, but 2 and 20 would, because if I multiply 2 times 20 gives me to 40, and if I make both of them negative, then I get this negative 22. So I split that into negative 2x and minus 20x, drop my other terms to give me the 4-term problem. And we're going to group this thing. So this is going to be factored a 2x, I'm going to factor that out, so it leaves me x minus 1. And here I'm going to factor out a negative. Be careful on this one, please. You got to factor out a negative 5. And this leaves me with an x minus 1. So one of my parts is going to be 2x minus 5, and the other binomial is going to be x minus 1. Okay, let's look at number 19. 19 through 22 here. Okay, so 3 times 2, that's pretty nice. That makes 6. I can list all the factors of 6, but I can easily find one that makes 5, because 2 times 3 makes 6 when you multiply, and 5 when you add it. So I'm going to split that up, so 2x plus 3x. What's nice about this problem is that all of the numbers are positive. So let's do a little factoring there. Factor out of x, so 3x plus 2. And here I'm going to factor out a 1, so 3x plus 2. So I got x plus 1 and 3x plus 2. That's how that works. Okay, so problem number 20. Sorry, I just got to keep my notes there. Okay, so problem number 20, 5 times 6. 5 times 6 is 30. Now the combination that needs to make a 30 and add to make a negative 17 is negative 2 and negative 15. Because negative 2 times negative 15 is positive 30. And if I add these up, it makes negative 17. So I'm going to split that up to negative 2x and negative 15x plus 6. And put the 5x squared in front. Group it. 5x minus 2. Group this. I got to factor out a negative 3 here. This is going to be a 5x minus 2. So x minus 3 and 5x minus 2. All right. I'm going to multiply 3 times 5, which gives me negative 15. I need to make negative 15 by multiplying and add to make 14. That's pretty great, because 1 and 15 will do it if the 1's negative, because 15 plus a negative 1 is going to be 14. So I split this up negative 1x. Oh man, I want to warn you that we never leave a 1 in front of the x for our final answer. But for this problem in the middle step, we can do that there to help us keep track. So there's our 4 terms of the problem. The first and fourth term was written, and the Atari split right there was drawn. So we're going to have grouping. I'm going to factor out of x, 3x minus 1. Here we're going to factor out a 5, and we get 3x minus 1. So this leaves me with x plus 5 and 3x minus 1. Okay, moving on to problem number 22. 3 times 4, which is negative 12. Now, the combination that works for this problem is going to be 3 times 4 that makes negative 12. But we want this to be a negative 1 in the middle, so it's going to be a negative 4 and a positive 3. This is going to give me my negative 12 if I multiply them, and it will give me a negative 1 in the middle if I add them. So if I split it up like this, negative 4x plus 3x minus 4, and in front, 3x squared. Now, I intentionally, for this problem, wrote it as negative 4, 3 instead of 3 and negative 4, just to be a little different and just to show you that it will always work. I'm going to factor an x out of the problem. So this leaves me with 3x minus 4, 1 power fewer. And you'll note here I can't actually factor anything out of this, so I can factor out a 1. And this gives me a 3x minus 4. So I write my x plus 1 first, and I write my 3x minus 4 second. And that gives me my beautiful binomial pair. All right, and again, I want to stress that you can easily fact check this by foiling. So here you have your 3x squared, your last term is going to be negative 4, and your inside terms, the negative 4x and the positive 3x, gives you your negative x in the middle. Okay, 6 more to go here, and we're getting to some of the bigger problems, problems that will keep you on your toes, especially after this one that I do here. The 3x and the 28. So for the first step, which is 3 times negative 28, this is going to give you a negative 84. Yeah, that is actually a pretty big number, but if you just take it one step at a time, you'll soon find your answer, because if you try dividing it by 1, 2, and then hit the magic number 3, 3 times 28 gives you your 84, which is what we multiplied to get it there in the first place. But you'll note that if I have one of these negative, like the 28, you'll get your negative 25 right there in the middle. So this is your magic split. We're going to have our 3x minus 28x minus 28 in the end, and the 3x squared in the beginning. Now we're going to group this thing. So 3, if I factor out a 3x, this will give me x plus 1. And here, if I factor out a negative 28, I got x plus 1, and that's going to give me my 3x minus 28 and my x plus 1. And that is my factored form. Now, I know what you're thinking about problem 24. Oh yeah, 3 times 18. Wait a second here. I'm noting that all 3 of these are divisible by 3, which means I can factor out a 3 and get x squared plus x minus 18. Wow, check that out. That is actually an easy trinomial problem where you just have to multiply 2 numbers to make negative 18 and add to make 1. Wow, that is really great. See, this is something that you should, whoops, I'm sorry, I said 18. If I divide that by 18, that should be a 6. Sorry about that. Sorry I missed that little spot. But you see what I'm saying? Like, if you factor out a common term, it's possible that you could get down to a problem that's much easier. So the 2 numbers that multiply to make negative 6 and add to make 1 is going to be positive 3 and negative 2. And that 3 that you factored out of the problem from the very beginning stays in front. So please be aware of that. Look for common factors. And after you found that common factor, you'll make the problem so much easier. Let's actually look at problem 25 and ask yourself, what's the common factor of 36, 6, and negative 12? Well, that common factor is 6, actually. So I'm going to put a 6 here and put some brackets. because this is still going to be a tricky trinomial, so I want to kind of like remove the 6 and then kind of make this 6 times smaller here, make this 6 times smaller here, and make this 6 times smaller here. Well, now I've got a very manageable problem, because I've got this easier, not an easy trinomial, but I've got an easier trinomial to deal with. Now I'm going to keep bringing this 6 down every time we do the problem, but I'm going to go through my 4-step plan to factor this. 6 times negative 2 is negative 12. Now what we'll do is we will take that negative 12 and look at all the factors that we could do to make a positive 1. Now the one that makes that right there is going to be negative 3 and 4. That makes a positive 1 when we add them, and multiplies to make negative 12 when we multiply them. So make a little split there. So 6x squared minus 3x plus 4x minus 2. Now what I'm going to do is do a little group in magic right there. And this is going to factor out a 3x, which is kind of nice. Factor out the 3x, which gives me a 2x minus 1. And then I factor out here a plus 2, and this gives me a 2x minus 1. Great. Now what I have is I have a final answer. And please remember that there's always a 6 in front of this here. So the 6 is continuously coming along. And this is going to encroach a little bit on the space over here. I'll erase this after I do the problem. So the 6, which is on the outside of all of this, is going to be multiplied by 3x plus 2, and then multiplied by 2x minus 1. Now, if you didn't factor out the 6, you could still get this answer and have either 18x plus 12, 2x minus 1, or 3x plus 2, and then 12x minus 6. But you would have gone through a larger list of possibilities than I did to get the final answer. Now to make room, I'm going to clear this off here, and let's cancel that. Alright, so for this problem, we're going to factor out a 4. Factoring out a 4 divides all of these by 4, so this is 4x squared minus 4x minus 3. Alright, so if I multiply my 4 times negative 3, I get negative 12. Now I have to look for factors that make negative 12 and add to make a negative 4, which is pretty great because I know that 2 times 6 makes 12, and if I make the 6 negative, then adding them would make a negative 4. So here I'm going to have my positive 2x and my negative 6x. I'll put my minus 3 over here and 4x squared over here. Alright, let's start splitting these up. And again, the 4, I'll bring this down and put a big bracket around it. So if I use grouping here, I'm going to have 2x split out, and this is going to give me a 2x plus 1. And what I'm going to factor out of here is I'm going to factor out a negative 3, and that's going to give me 2x plus 1. And again, in brackets, I'm going to have a 4 on the outside. So that means I have 4 times the quantity of 2x minus 3 and 2x plus 1. Now you could have maybe factored out a 2 instead of a 4, but by doing so I ended up with a much smaller problem to deal with on the inside of the brackets. Okay, so for the last two, problem 27 and 28, it would be foolish I tell you, to not factor out a common term, and in this case 27, you're going to factor out a 3. By factoring out a 3, you're going to get 4x squared minus 11x plus 7. Alright, so with that in mind, we are now going to multiply the 4 times 7, which is 28. And the two numbers that multiply to make a positive 28 and add to make a negative 11, which means that these numbers both have to be negative, is 4 and 7. So if I split this up to a negative 4x minus 7x, you can see that this is going to be a whole lot of factoring out 1s and just some simple numbers here for this grouping problem. So this factors out a 4x, which leaves me with x minus 1. Here I factor out a negative 7, which is going to be an x minus 1. So, bringing my 3 down with me, 3 is then going to be multiplied by 4x minus 7 and x minus 1. And there you go, problem 27. And so for our final problem of this section, let us look at factoring out a 2. because a 2 will divide all of these and cut them in half. So here I have 2x squared minus 9x minus 5. And so what I'll do is multiply 2 times negative 5, which is negative 10. Alright, so with that negative 10, I'm going to find two factors and make a negative 9, which is easy because 1 and 10 make a 9, as long as the 10 is there to make that negative 9 there. So here we have 1x, and again, we would never leave that in a final answer, but it's great to help us out right there. And the 2x squared in front. Now again, outside brackets we did factor out a 2. We'll keep bringing that down. Factor out of x, so 2x plus 1. Factor out a negative 5, so 2x plus 1. Whoa, didn't write my 1 there. Ha, thought I swiped it. Alright, so put that in brackets with the 2 on the outside. So for our final answer, we have 2 multiplied by x minus 5, and then 2x plus 1. Alright, well thank you for making through this little lengthy video here, but hopefully a good one as you practice doing some tricky trinomials, where the first term was not 1.